All right, let me take you through this partial derivative, whereby you're being asked to show that this expression is equals to 6 into x cubed minus y cubed when v is a function of x and y given by the whole of that expression. Now, for you to go about this one, we are going to get the first derivative, the first partial derivative, of this expression, then get the second derivative. Now, the first derivative, we are going to get it with respect to x as shown here, and then the second derivative with respect to y. So before you go to the second derivative or the second partial derivative, you start from the first partial derivative, then you go to the second partial derivative with respect to x, and then with respect to y. So we shall come up with two equations, which later on we shall come and substitute in the first equation here, and so as to try and make the left hand side of the expression to look the same as what we have in our right hand side of the expression. Let's begin. Now, the first partial derivative with respect to x, that is curl dv by dx, is going to be, now with respect to x means we are going to keep y the constant. We have x cubed plus y cubed, right? So we are going to differentiate x cubed, but we need to remember that when you take x cubed alone, the value of y there is to power 0, right? And again, we said y is going to be kept constant. So in this case here, when you take y cubed, and since we are differentiating with respect to x, right, our x here is going to be power 0. The essence that the value of x is absent here means it is not absent, but x is to power 0, right? And then we proceed to 4m, those are constant. Another constant we say is y cubed from this expression, and then we proceed to differentiate with respect to x, x cubed. Let's differentiate now. Y to power 0 here is 1, and that one is multiplied by differentiating x cubed becomes 3x squared plus y power 3, and then differentiating x power 0 is like differentiating a constant, because x power 0 is always any number raised to power 0 is always 1. So differentiating a constant like 1, you will always get a 0, right? And then subtract 4m y raised to 3 times 3x squared after differentiating over there. So by simplification here, we shall have 3x squared plus y raised to 3 multiplied by 0 will give us a 0, obvious. So that one will disappear. So we are left with 4my cubed times 3x squared. So I shall multiply 4 by 3 to give me 12 multiplied by m by y cubed and by x squared. So this is the first derivative. This is the first derivative with respect to x. But according to the expression, we need to go up to the second derivative. So the second derivative, we differentiate this one further. So it becomes curl d squared v by dx squared is equals to, again here, we have only x power 2, but it does not mean that our y is absent. It is there, but it's only that y is raised to 0. And since we are keeping y constant, we don't need to put it there because we shall be multiplying by 1 at the end. So we simply differentiate x squared here with respect to x minus 12 m. Y also is kept constant in this case, and we differentiate with respect to x, our x squared on this side also, so that we shall have here 3 times 2x. Differentiating this one, you get 2x minus 12m y raised to 3 times 2x after differentiating over there. So it means that our second derivative with respect to x, our second partial derivative, I mean, with respect to x will be multiply 3 by 2, you get 6x, subtract, multiply that 2 by 12, you get 24m y cubed x. So let's call it equation 2, because our equation 1 was the original equation there. Now we are through with the second derivative with respect to x. Now we proceed on to first and second partial derivatives with respect to y in that expression. So the expression here is x cubed plus y cubed minus 4mx cubed y cubed. Now when we differentiate with respect to y, we are going to keep our x constant, so our x is going to be constant, and in this case we are going to differentiate y power 0. Remember I said when you don't see y anywhere, it means it is there but it is raised to power 0, and this one is added to x power 0 is kept constant. We differentiate with respect to y power 3 minus 4m, x is kept constant. We differentiate y cubed. Right, now by simplifying here, we shall have x cubed, and again I said differentiating y power 0, you shall get a 0 because it is just like differentiating a constant, so we shall get a 0 there, and then plus x power 0 is 1 multiplied by this one is 3y squared, subtract 4m x cubed times 3y squared. So the first derivative with respect to y, we shall have here a 0, so this one will disappear, and this simplifies to 3y squared, I mean, subtract, multiply by 4 by 3, you get a 12m x cubed y squared. So we proceed on to evaluate the second partial derivative with respect to y by differentiating this one further, and if you differentiate here just like we did before, we shall get 6y subtract 12m x power 3 times 2y, and this one simplifies to 6y minus 24 mx power 3 y, call it equation 3. Now our equation 3 and 2 here, 3 and 2, we are going to substitute it in our original equation. So what was the original equation? The original equation was x squared by second partial derivative with respect to x minus y squared times second partial derivative of v with respect to y is equals to 6 into x cubed minus y cubed. Now we are going to pick the second equation here and substitute it here, because second derivative gave us that equation. So that is we take now x squared multiply by 6x minus 24m y cubed x, and then subtract y squared into 6y minus 24m x cubed y. All right, so let's simplify this expression and try to make it equal to what we have in our right hand side of the equal. So this is what we have in our left hand side. So by opening the bracket, we shall have 6x power 3 minus 24m y power 3 x power 3 minus y 6y power 3, I mean, when you multiply that one, and then this negative times that negative becomes plus 24m x cubed y cubed. Now from this expression you can see that we have 24my cubed x cubed and 24mx cubed y cubed. These are like terms, and since here is a positive and here is a negative, it means these two shall cancel out. What is left is this and that one. So we shall have 6x power 3 minus 6y power 3, which is the same as when you take 6 outside. This one is x cubed minus y cubed, which is the same as what we have on our right hand side of the equal. Thank you very much for watching. This is how you go about solving such a problem. Until next time, may God bless you.